Hi, welcome back to part 2 of this stream on Go stuff. I had an internet snafu and apparently it went away for a while and just eventually disconnected. So sorry about the where I dropped off, so I'll pick up where I think I was roughly talking, but I honestly don't know how long I was totally out. So I was saying that with the Go stuff, there's an option to use TLS, and you could get certificates and you could put your stuff up on a virtual private server using something like DigitalOcean, or there are many other vendors out there. This is one that I've happened to use in the past. And you could integrate with systemd, have some startup files. You could do a bunch of this stuff by hand if you wanted to. But I think what I was getting to before I was so rudely interrupted by my stupid internet is that I think what you'd be more likely to do is work with something like Fly. And with Fly, or Heroku, or many other vendors, you could have something where, in fact, what you're doing is making your app work over HTTP, and they have some kind of routing layer in front that can handle TLS termination, so that the connection is still secure between your owned IP address that you reserve with Fly and the machines that are receiving it, but you don't have to set up TLS directly on the machine, so that you'd be able to serve something like your server just like this over a port that you want, and then Fly could connect to that and like hand the unencrypted traffic to your machine. So that's, I think, a more likely route for most people. And maybe that's what we'll do. I do have a Fly account. It's been a while since I've used them. In fact, it's been probably over a year, maybe not quite 2, but definitely over a year. So I don't know how things have changed. And I was not even like serious with it at the time. So I'm no Fly pro by any stretch, but it might be fun to try and deploy up there. All right, so let's take a look at the next bit of what we want to do, which is to say, let's get a router going. So we have an interface that is expected by the handler package, and sorry, the server, and it's the thing that it's looking for is called handler. And so here's the type that you want to be able to provide. You don't have to do this yourself. The challenge with some of the stuff is it's not, in my opinion, it's not super clearly named, unless you're pretty nerdy, which maybe you are. But we want to look for something called new serve mux. All right, so let's talk a little bit about serve mux and what this thing is. Serve mux. That's where we get to this word right here, multiplexer. So mux is short for a multiplexer, which is, well, I remember it more from my electronics classes, frankly. Define multiplexer. Plexor? Nope. Spanish version, apparently. Plexer. Yeah, this is what I remember from my electronics classes. So it's a little bit odd for me to see multiplexer be used in the context of software, frankly. That's more because I have an electronics background, and it means something quite specific to me. But effectively, a multiplexer allows multiple things to come in and multiple things to go out, and maybe that's where they're thinking there. Here's like Go's version of a multiplexer is they can match on different routes of your choosing. So this is where we may want to pull up some examples of a multiplexer, because I remember it and I know it. And you would the easiest way to think of a multiplexer is like the best name is a router. So we would want to create a router, and we'd want to, and so I guess I should point out maybe 2 things. when you are declaring a variable in Go, you have to use a colon equals when you actually declare it. So like you can't just say router equals and then do the thing, because it's not a declared variable. So there's a difference between declaring something and putting something in it. So they sort of separate. So like let's say you wanted to say router is an integer we wanted 42, and then we want router to be 24. Okay, so in both of these contexts, router has not been declared yet. So if we first declare it, and then now we can actually assign to it and change the value, but the first step is it has to be declared. So that's a little bit different from languages that like Python, which don't have a different operators for separating declaration from like assignment, but Go does that. So if you're wondering what the heck is that colon, that's what it's doing there. So first time you see it, took me some getting used to on that, frankly, but that's how it is. So we want to say new serve mux, and it returns us a serve mux type. Let's accept that. And what I can't remember if you add a handler func, or I think it's a handle func. I think that's what we want. Handle func registers the handler function for the given pattern. Yeah, that's what we want. So if the given pattern conflicts with one that's already, so we use this handle func thing to register a bunch of different patterns. We have to do this we have to do it one at a time. That's what I can't remember. I thought there was a way to like do a bunch of these at once. So that's what's unknown to me. So let's take a look, see if they provide any kind of examples. So here's new serve mux. Handle is like what, so I think under the covers, well, hold on. Handle registers the handler for the given pattern. Well, what's the difference between handle and handler func? Oh. Maybe it's the signature that it follows. Handler, so handler is something that follows this interface, where it has a method that accepts a response writer and a pointer to a request. So handle func is instead, you don't create the type that has that start response, or what was it called? Serve HTTP. You don't do a type that has a serve HTTP method on it. You instead just declare a function that has that signature. So that's the difference. Okay, so it looks like you call these things multiple times. And curiously about this, you can see, so what you get from this is a little different from, like, I talk about Django a bunch, and I've shown a lot of views on this. And with the Django worldview here is you create a view function, and the view function receives a request input, and it returns a response output. In here, they're saying, no, don't bother returning anything. We're going to give you a writer. And if you want to write some content, you use this response writer and write to it using a bunch of different patterns, like an fprintf here, where it follows the writer interface that is very common in Go. So I've actually seen this before in Python, where it's the same kind of idea, where you get request and response are both passed in as arguments to whatever your function you have, or I guess they become parameters inside your function, you know what I mean? But if we want to take a look, we've got Python Falcon is the web framework that I remember this from. And you can see the way Falcon does this is you declare a resource and you route to it. So there's a little bit more ceremony with what they're doing here. They're making a class, and they're saying, like, on get methods, you're going to get a request object, and a response object will be created for you, and then you put the data into the response object directly. So it's similar, but it's not using a writer style, where the writer in this context is more like write some raw bytes. So this is a abstracted above this, but it's one thing that sprung to mind when I saw this pattern of having a handler func, of just making both parameters to your function that you need to have. So let's try it out. They call it mux. I'm calling it router because the router is a more natural name to me. So we want a handler func, and we want to give it a pattern that it's going to recognize. And this is where the reason I wanted to show Go 1.22 is that the pattern stuff for 1.22 got a lot better than previous versions. There wasn't a lot of power in this before. So previously, the things that were available to you weren't that great. I think now this might be cool. I suspect that this variable may know how to expand the type that's needed. Oh yeah, check that out. That's awesome. So Go Please knew that this second argument to this function was a function in and of itself of a certain interface that takes a writer, takes a request, and that's it. So just by following the little snippet completion, we get that whole thing filled out for us. That's pretty cool. So let's do, just like we saw on that, let's do format f printf. And so f printf takes a writer as its, like, I think the F stands for file, maybe. So you can normally think about IO writer as some kind of interface to a file. Ultimately, so many things in the Unix world ends up being like file-like objects. And we can say fprintf, give it the writer, and say hello from the handler. All right, so now let's get a little space here. Now we've got, oh no, we haven't hooked anything up yet. So I think the last thing to do is take the handler and pass it the router. The router follows the handler interface, and the router's again, the router's a mux. If you want to stick with that language, I don't actually think I like it. And so, hold on, probably two things here. So here's an example where I added this new thing. One of the things that Go does, and one of the things that Go Please does, is it hooks up into my automated formatter stuff here. So when I'm hitting save, it's actually running Go format, FMT. It's a command that's available to Go. Look at H, you can see there's the FMT, and